So we'll take a look at the topology. Hopefully I can get the pointer.
It sort of works.
Yeah, I didn't bring batteries with me. I think it's dead.
No battery to use.
AAA. No? All right. So I can't point yet. We'll talk about it. So for people that have seen logical topologies, this is a little bit different than your standard logical topology. I drew it so that we could have physical and logical on a converged chart. So I'm going to explain it. It's the topology that's back here. So the bottom switch back there is going to be our storage switch. The storage switch is connected to everything but the fuel master node, and I don't have 10 gig switches back there, so they're running 2 gig lags. The top switch is going to be pretty much everything else. So with OpenStack, you have management network, the public and floating, which we'll talk about a little bit when I do the demo, storage network, and a private network. In this case, we're using Neutron and GRE tunneling, which means we don't need to create a whole bunch of VLANs. All the separate private networks for each user are tunneled through the management interface. So that's going to be the kind of curved dotted lines, everything's color-coded. So you have those 192, 168, 111, and 112 networks are being tunneled over the management interface. And then you have, to get out to the internet, you have the ClearOS gateway back there. So you have the link going out to the sandbox and a 3 gig lag. On that, you have the Pixie Boot, the fuel network. So that's how it's going to pull down updates when it does deployments for any of the nodes that are back there. You got the management network, doesn't really need IP3 connectivity, but I have it on there so it's easier for me to connect to it. And then you have the public or floating network. So each of those nodes has a public address. The scope is, that's going to be the 252.0 range, it's 10 to 240. And then when you have a floating IP, which is how you're going to connect to your VM, that's 253, 10 to 40. So in the same range. So we've got, Marcus still has a pointer.
Yeah, he's trying to find the batteries.
Okay. So I have this is a small subset of the actual services that run on OpenStack. So the master node has the fuel web interface, which we'll take a look at. It's the puppet master, so that's how you get your automated deployment of all the other nodes. So you can deploy up to 100 servers without having to go in and do configuration on each one. It's going to run DHCP and DNS mask. That's for addressing to the other nodes, and it modifies its own host file, so that's how all the nodes are able to communicate with each other without their own DHCP or without their own DNS entries on another server. The control nodes all run clustered services, so they run stuff like MySQL database, they run RabbitMQ, which is the server end for that. And then the big OpenStack ones are Nova, which is going to handle the compute configurations, Glance, which handles image storage. So an image is like a VM template, basically. You have Cinder, which does block storage. So you can actually create storage and attach it to a VM. We're going to look at that as well. Horizon is the dashboard. And then the big high availability trio is CoroSync, Pacemaker, and HA Proxy. They're a set of services, and essentially what they do is on the controller nodes, they manage the virtual IP address and the clustered services. So you'll have a node that's selected as master. It'll have a virtual IP address. It'll start up services, and then in the background, it will monitor the other nodes. And if the master node fails or any of the services fail, it will restart on another controller. Excuse me. Neutron is a big networking component, so it handles all the layer 3 addressing for VMs, DHCP, uses Open vSwitch, and then you have a couple of the other Nova modules are the scheduler and console auth. So that's how you get console authentication. It generates a token whenever you try to connect to the console, and scheduler is how VMs are launched. So I mentioned Ceph storage already. Ceph storage has 2 different roles. It will run, the control nodes will run a monitor to monitor all the Ceph storage nodes. And then Ceph is clustered storage. We'll probably take a look at the configuration for that. But It's basically RAID 1 or RAID 10, depending on how you have it configured in software instead of on a hardware RAID controller. So the cluster back there right now, the storage nodes have 6 drives, 6 500 gig drives in RAID 0. And then Ceph handles the replication between those nodes. So if one of the arrays or one of the drives goes down, all the data on that is already replicated onto another node. So the last compute node, I have some example of projects. You run a domain controller, DNS server, scale-out file server, and then another project can run KVM, which is what we're going to look at here. You can run a network file server, and then you can also run ESXi vCenter server. So you'll see up here that I have an admin and Vert1 projects. That's what I currently have on the cluster. They can actually have the same address space. So you could have 6 different people that are all using a 192.168.111/24 address space. So for the instructors, when they write up labs, they can write up labs all with the same IP addressing information, and every student can use that same information. You don't have to worry about running over each other's address space.